In this TI DLP Labs training module, we will look at the standard specifications used to denote how a projection system performs. This presentation will define throw ratio, offset, and telecentricity, as well as exploring the design trade-offs inherent to these properties. Knowledge of these concepts is crucial to understanding the limitations of projectors and selecting the type of system best suited for a given application. Throw ratio describes the image size a projector creates when placed a set distance from a screen. To calculate the throw ratio of a projector, you divide the distance between projector and screen by the width of the projected image. Systems with smaller throw ratios can create large images even when placed very close to the screen. Different projectors exhibit a wide variety of throw ratios, ranging from greater than 1, called long throw, all the way to less than 0.4, called ultra-short throw. Shorter throw ratios allow the projector to be placed very close to the screen. This is advantageous because they can be used in smaller rooms and there is less likelihood of people or objects blocking the projected image. However, short throw systems require more complex optical designs that may use more and larger lens elements. This increases the total size and cost of the projector. They are also more sensitive to screen imperfections or misalignments. Any curvatures or bumps in the screen, or relative tilt between the screen and the projector, will be more visually noticeable than when using a long throw system. Offset is a shift of the DMD position relative to the optical axis of the projection lens. This shift creates a corresponding displacement of the projected image. As depicted by the diagrams below, the projected image of a 0% offset system extends equally above and below the optical axis of the projection lens. In a system with 100% offset, the projected image is entirely on one side of the optical axis. Offset is most commonly used so that a projector mounted flat on a table or ceiling can still display a full image on the wall. Without any offset, the table or ceiling would block half of the image. Some projectors are designed with a fixed amount of offset, while others can be adjusted by moving the projection lens. Designing a system to accommodate larger offsets increases the size and complexity of the projection lens. It is important to clearly define what amount of DMD shift corresponds to what percentage offset. 100% offset is obtained by shifting the DMD half of its height, so that it is entirely on one side of the optical axis, and the image then appears entirely on the opposite side of the optical axis. It is possible to design systems with greater than 100% offset. For example, shifting the DMD 3/4 of its height would be 150% offset, and shifting the DMD by its full height would be 200% offset. Projectors often have 100 to 130% offset. Offset can exist in both the vertical and horizontal directions, although vertical is far more common in projectors. The illumination architecture of a projection system can either be telecentric or non-telecentric. In a telecentric system, the angle of incidence of light illuminating the DMD is constant at all points across the DMD, and the optical pupil is located at infinity. The illumination angle in a non-telecentric system will vary across the DMD, and the optical pupil is located a finite distance from the DMD. Telecentric systems require a prism to separate the illumination and projection light paths. This prism structure utilizes total internal reflection at an air gap to act as an angular filter. Non-telecentric systems do not need a prism, but instead use offset to separate the illumination and projection light paths. Telecentric designs offer several performance advantages. They typically have more uniform brightness levels across the image. These systems can have adjustable offset by shifting the projection lens relative to the DMD. Adjustable offset is used to change the image position relative to the projector for system installation in different locations. Since the optical pupil is located at infinity, it is relatively simple to interchange different projection lenses with the same illumination optics. However, the prism does add cost and weight to the system. Non-telecentric designs are less expensive because they do not require a prism, but come with other limitations. A 0% offset design is not possible because greater than 100% offset is typically needed to separate the illumination and projection paths. Adjustable offset is also not feasible. In review, there are several common metrics used to describe the performance of a projection system. Throw ratio compares the size of a projected image to the distance over which it is projected. Offset is a shift of the projection lens relative to the DMD and is used to move the image position relative to the lens. Telecentricity is a description of the projector's illumination system that is accompanied with performance trade-offs. Understanding these concepts allows one to select a projector most suited for a particular application. For more information on this and similar topics, please visit ti.com/dlp. Thanks for watching.